Moving on to question 2. Another small question. Glucose is very important. Yes, it's a very important energy source to humans. Determine the molar mass of glucose. I can tell you right now the answer is 180 grams per mole. But of course, we have to show some working out. And no, you don't need to remember this off by heart. I think I just done it too many times. I could be wrong. That would be embarrassing. That could happen. 6 times molar mass of carbon and 12 times molar mass of hydrogen and 6 times molar mass of oxygen, which equal to something. Alright, molar mass of carbon is 12, and then plus 12 and plus 6, 6 times 16. Yep, answer 118 grams per mole. And yes, I remember this. Calculate percentage by mass of carbon in glucose. So percentage by mass of carbon is basically the mass of carbon over the molar mass of glucose as a percentage. That's not good enough. My 6 looks like an O. O6. Now the mass of carbon here is not 12. You actually have 6 of it. So it's actually 6 times 12 over 180. Let's do a percent here. So times 100. So 72 divided by 180 times 100. I don't even know why I had to times 100, to be honest. It's 40%. Okay. If a student consumes 1 grams of glucose, calculate the number of molecules consumed. Alright, summarize the question again. The mass is provided. Mass of C6H12O6 is provided to be 1 gram. And in part A, you need to work out the number of molecule, which is capital N of C6H12O6. So this is when you need to combine both of the triangles or both formulas. Now the first one, which was drawn way too big, is this. So you have mass, number of mole, and molar mass. So if you want to work out well, it basically allows you to use the information provided, which is the mass of glucose somehow. And the second triangle that you potentially can use is this one, which has number of molecules, which is what you ultimately need, number of mole, and Avogadro's constant. Okay, so what I am going to do, because I will start with the mass, and I'm going to use it, and also I'm going to use the molar mass that I just calculated earlier, or in my case actually memorized, to find the number of mole of glucose, and then I'm going to use it to work out the number of molecules. So the number of mole of C6H12O6 is mass over molar mass, which is 1 over 180. Not that we care, it's 0.0056. You can just leave it as a fraction, that's okay. It's actually encouraged because you do need to keep all the exact values. So this is the number of mole. And from here, you should find the number of molecules quite easily just by multiply the number of mole. Oops. Let's try again. Multiply the number of mole with Avogadro's constant. So multiply with 6.02 times 10 to the 23, blah, blah, blah. I got I just said blah, blah, blah. I don't know why. 3.34 times 10 to the 21. Unit molecules. That's final answer. Ooh, okay. Number of atoms. Number of atoms is also big N. And if you look at the formula of glucose, you have 6 carbon, 12 hydrogen, and 6 oxygen. So the total number of atoms in one molecule of glucose would be 24. So if I want to work out the number of atoms in 1 grams of glucose, I just need to multiply the number of molecules by 24. And I'm just going to use the answer from part A. Sorry, not part A, the previous part. And multiply it by 24, so I get 8.03 times 10 to, I don't know why my handwriting just get bigger all of a sudden, 22 atoms. And I think that's it. Is there anything else on this question? No, we're good for question 2.